Hello. So here we have some of the problems, numerical problem based on electric energy and power from class 10th. So uh, okay, find the work done to move each coulomb of charge across a region of potential difference 5 volt. A quite easy question, but we need to think about it. We know V equal to, just a minute, we know V equal to W upon Q, so W equal to VQ. So it's quite simple. Work done will be V, that is 5 volt, multiplied by Q, charges each coulomb means 1 coulomb. That will be 5 joule. You should know that the unit of work is joule. Energy is also joule. Okay, moving on. When for each of these questions, pause the video, give it a try, and after that, just see the solution. Okay, calculate the electrical energy to transfer 2000 coulomb charge across a cell of 50 volt in 2 minutes. Electrical energy, we have different formulae: VQ, VIT, I square RT, and V square T by R, and also power into time. We have these much formulae for electrical energy. We have charge here, we have potential difference here, we have time here. So you can find any of it. Plenty of information is given. So some of the student will go with this time and this value of charge, and I don't know what will they do, but see, if in the question many things are given, just see what is useful for us. We want electrical energy. See the first formula, potential difference into charge. There is charge, there is potential difference. No need for this 2 minute. V multiplied by Q, that is 50 multiplied by 2000 in joule. I'm not writing final answer. You can calculate of your own. Then comes this type of problem. Which of the following lamp will glow more if connected in series or in parallel across a source of 220 volt? For lamp A, these are the specification. Lamp B, these are the specification. Uh, this is in our practical, in our daily life also. If you see any appliances, its power rating has been given in this way: watt and then volt. First thing I want to clear, it means if this device have been operated at 220 volt, it will consume energy at the rate of this. And same for here. If you operate it at 220 volt, if you are operating it at lesser voltage, it will not consume that much of power, that much of energy. I've used the term rate of energy, that is power. Okay, so what are we going to do? First of all, find resistance, because whether it is series, whether it is parallel, resistance will remain same. So this is P, uh, P for A, this is V for A, this is P for B, power, and V for B. We know a formula, P equal to V square by R. So using this formula, we can do just little bit of cross multiplication. So we will get, or not this, what is this? we will get this. R equal to V square by P. So RA is equal to V square by VA square by PA. That is 220 multiplied by 220 divided by 100. This is 22 multiplied by 22. That is 484 ohm. Same here. RB is equal to VB square by PB. That is 220 multiplied by 220 divided by 60. This time it won't work. So 4840 by 6. I can further simplify it, but I'm not simplifying it. I'm leaving it as it is. Okay, so next, moving on. In series, we can see that oh, I'm solving it. Approximately, this will be the answer. It means resistance of B is greater. In series combination, current will remain same. In series, current will be same. So heating of A will be I square RAT. That is I square RA is 484 T. Let us suppose for given interval of time, and H of B is I square 806.3 T. For given period of time, this will be heated more. So here clearly HB is greater than HA, so B will glow more. Okay, now there is not much space is left. It means for second part, for parallel, there must be some trick. So remember, in parallel, you can write in parallel potential difference remains same. So both lamp will be operated at 220 volt. In this case, the lamp which has more power, rating, will glow more directly. A will glow more. Remember this thing. See what happened in this question. There were two lamps connected first in series, then in parallel. So which will glow more? So we can't say anything until or unless we have the information of resistance if we're talking about series combination. So in series, current remains same. We don't bother about to find current, because it is just they want which will glow more. Just we have to justify it. So we have just analytically we have put the value here, and we can see, we can compare HB is more than HA. But in parallel combination, because in parallel combination they have been connected to 220 volt, which is their recommended potential difference. So at their recommended potential difference, they will perform as their power rating is given. So here in parallel combination, uh, they will perform according to their power rating. because potential difference is same as that of their power rating. So the lamp which has more power rating will glow more. Okay, this one is most important question for board's purpose. What is the commercial unit of energy? So commercial unit of energy is kilowatt hour. This is commercial unit of energy. How is it related to joule? So 1 kilowatt hour is equal to 1 kilowatt multiplied by 1 hour, which is equal to 1000 watt multiplied by hour, that is 60 into 60 seconds. So it is 3600 and then 3 more zeros watt second. Remember one thing, 1 watt is equal to 1 joule per second. So 1 watt multiplied by second is 1 joule. So this much watt second is equal to this much joule. And according to scientific notation, we can write it like 3.6, and to balance it I have to put 10 to the power 6 here. So this is the relation. And see, whenever we solve such type of question in which power rating has been given in terms of kilowatt watt, we have to convert it first into kilowatt, we have to convert time into hour, and then we can easily solve it. So for that purpose we have this question. It is going to be a lengthier question, so in this can easily solve it. 40 watt for 20 hour a day. Remember, if we want to calculate bill, then remember this order: number of device, okay, then multiply power in kilowatt with time, and then what you can do is you will do it and take the sum that will be for 1 day, then for required day multiply it with, then it is totally mathematical part. But why are we doing this power into time? We have to find electrical energy, but it is because power equal to energy by time, so energy is equal to power into time. All right, so we'll start. Two lamps, so I'm writing lamps, number of lamps is 2, power is 40, but we'll not write 40, we'll write 40 upon 1000. Now it is in kilowatt, and then 20 hours multiplied by 20. Then there is microwave 1 it is, and 1.5 kilowatt, it is already in kilowatt, we are not changing it. Okay, for our understanding I'm writing kilowatt hour here, and it is used for half an hour. Then there is heater, two heaters, um, heaters, 2 into 600 divided by 1000 multiplied by 2 hours. And finally, one refrigerator, 1 into 100 watt divided by 1000 into 10 kilowatt hour. So it will be 1.6 kilowatt hour. Kilowatt hour means electrical unit, commercial electrical unit. And this one will be 0. Am I doing some mistake? No, everything is good. Okay, so that will be 0.75 kilowatt hour, and this one will be 2.4 kilowatt hour. Am I right? 2400 divided by 1000. Yes, 2.4 kilowatt hour, and this will be 1 kilowatt hour. Okay, adding them all, we will get for one day is equal to is, yeah, electrical energy for 30 days for March. Sometimes they can February, and leap February, that also 30 into 5.75, that will be okay, this much kilowatt hour. Now cost, so rupees 5 multiplied by 172.50, so final answer will be this one. So here it is. So I have shown here all the possible questions, and time to time I will bring some more interesting and some thought-provoking questions. Bye bye.